We're going to be talking about the Sensit HXG-2D combustible gas leak detector. If you can, use the chat window. I have it up here on another screen. If you have any questions, ask them as you go in context. I find that's a little bit better than waiting all until the end. And then if I'm going a little bit too fast paced and other people there saying, hey, I'm getting lost, ask me to slow down, just send me a chat on that real quick. So we'll be talking about the instrument technology, actually what makes it up. Of course, the BPI 1200 requirements, which is one of the reasons why you're using this product, how the instrument works, how it runs. If you have one with you, it'd be great to be looking at it as we go through that segment of the morning, and the instrument maintenance, and then a knowledge retention quiz, which Sean should have sent to you beforehand. We're just gonna, if you do have it and you'd like to actually take the test, let me know. Or if you just want to take a few minutes on each question, ponder it over, and then we can go through the answers. It's more of a checking your learning, making sure you got everything you need from this webinar. So a little bit of background on me. I've been doing instrumentation development, product manufacturing, sales, marketing for a number of years now. I've got a real strong technical background, and I've also had a lot of fun training people, and that's why I do webinars like this for good clients like Clear Result. TruTech Tools, we're in our 12th year of business, and we offer about 70 different brands of building performance and HVAC tools. Here's a picture of the TruTech team taken this last June, and we're proud of the work we do and the way we help contractors and technicians do better work. And some of it comes through better understanding of the products you're using. So again, one of the points of the webinar we're having today. I also do a couple of podcasts if you're into that thing, Building HVAC Science, and then Res Talk, which is done for ResNet, for the home energy rating system, the Res Talk or the ResNet group. So those are two different podcasts. Just type those in any podcast or browser. You can find those podcasts if you're interested. So here's a quick overview. The product, mainly the ones we sell are dedicated for methane. And methane is the major component of natural gas. And that's usually the fuel of choice, except in certain locales, there's propane being used. So if you request it, by special order, we can calibrate it or have it, you delivered one that's calibrated on propane. And you'll see the subtle differences as we go through the technical aspects of this. It's the same unit, but it gets calibrated on a different gas. So when you get the unit, it includes a carrying pouch, the batteries, a wrench to actually open up the battery compartment, and an instruction manual. A wrench to open the battery compartment. You may say, what the heck, why is that, what's that all about? This instrument is actually designed for gas utilities and fire departments, and they cannot afford to have batteries falling out on the job. Okay, it's not that it's a weak design, but it's absolutely, its suspenders and belt, it's going to stay in place. That battery cover is going to stay in place. So it's got a digital display where it shows the information about the concentration of measurement. 3 software buttons. There's no mechanical buttons or switches on it. It's an electronic device, digital device. A flexible gooseneck so you can extend and get that sensor into the right area to see, to sense the gas and detect it. And of course, an alarm LED to tell you if you've overrun the alarm condition. It does have an audible alarm, but in addition, a visual alarm. So features in a push button operation, we talked about that already. It is field calibratable. That means you can get a calibration kit, install it, and you can readjust it to give you that digital accuracy of the display. It's not a complicated process. We also do it at TruTech if you're interested. And it's something that you can do yourself, or you can send to us or back to the manufacturer for calibration. Calibration interval usually recommended is 1 year. It has a backlit display, which you can toggle on and off with the button. The buttons have 2 labels on them. So in certain modes, when you press and hold, you get one function, and you get the other function. Like in this case, you tap the C button, which has the word light on it, and it turns the light on for a 60-second or 30-second cycle, excuse me. It also has adjustable alarms. They're field adjustable, but generally speaking, the way it comes delivered to you is the way you're going to want to use it. The sensor in it is a semiconductor sensor for sensing the gas. We'll talk about it actually a little bit more detail. It is a low-cost sensor. They run about $45. So it's a little bit different than some of maybe the combustion analyzer sensors you're used to, which are usually well over $100 to $200. This is $45 for this sensor. It has a direct readout of ppm, of parts per million. Now, this is not a carbon monoxide analyzer. This is a gas leak detector and a gas concentration meter. So it's actually measuring ppm of gas. And that's a little bit different. We'll talk about what that actually means. What is ppm when you're coming to gas, and what does it have to do with the explosive concentrations? The next measurement it has a direct LEL, which is a lower explosive limit readout that goes from 0 to 100% of the explosive limit of the gas it's calibrated for. And again, we'll go through a chart of all that and what that means. There's a digital tick control that helps you find leaks faster. Basically, it's a resettable threshold that you can put in the product. So it's sort of like if you're familiar with Leakator 10s from Beckrich, great product. That product has a thumb wheel dial to allow you to adjust the clicking threshold at which it's sensing the gas. You're actually changing a control inside the instrument. This one does it with a digital control. So again, it's not a carbon monoxide meter. It does not measure CO. It's not a refrigerant leak detector. We'll talk about cross sensitivities a little bit later. It will pick up some other things, but its main purpose is to detect combustible gases. So even though you're not in the business, the utility or the fire department emergency response business, the reason why BPI has people going out there and checking for gas leakage is it's a safety issue. It's safety for the occupants, the owner, and people working in the building. So I'm not going to go over and read this kind of horrific scene here, but you've probably all heard of this happening. It tends to happen a couple times a year. You'll see it in the news. You want to make sure that you're conforming with government and industry standards. And in this case, it's the BPI evaluation of gas leakage is the standard you're conforming with, the BPI 1200 standard. So getting right into it, a combustible gas itself, just the gas itself, has different ways it responds to concentration of air and gas. And what happens? Will it support combustion? Is it have too much gas, in other words, too much fuel, and too little air to actually combust or burn? It's in the combustible range here, the red range, middle bar, the bottom range, the green. It's too lean to support combustion. And so this is the concentration of gas compared to the air. So you go from 0 combustible gas all the way to 100% combustible gas. I think everybody can imagine that at 100%, there's just no oxygen around because you need oxygen in order to combust. I think you probably all know that from your combustion training classes. Sorry about that. Going the wrong direction. Okay. Sometimes the lower explosive limit or the area where you enter from really too little fuel for the oxygen available to have any combustion into the explosive range can also be called the lower flammability limit. So just for sort of the trivia folks out there, LEL is the same thing as LFL. Then the upper explosive limit is the one you pass through in which you have too much fuel for the oxygen available. And at that point, you're not able to combust because there's too much fuel to oxygen ratio. Sometimes that's called the UFL, or the upper flammability limit. So above the upper flammability limit or upper explosive limit, it's too fuel rich to burn. Within this range, the middle range where it supports combustion, it can burn or explode if an ignition source of heat or spark or flame is introduced. And below it, it's too fuel lean. There's not enough fuel for the oxygen available to burn. The concern here is if you ever enter this range, this is why you want to actually take a measurement. If you ever enter this range where you're above the upper explosive limit, the UEL, and the air clears or it blends with fresh air, you'll move back through the combustible range. So that's why it's important to know these different limits in the concentration. And we'll talk about the sort of the action level for BPI as we get into the standard. So again, there's caution between when moving from the UEL, even though it's too rich to support combustion, when the air clears, you could get into a range where it will. So you got to be very careful about if you're ever in above the upper explosive limit. So the typical measure for concentration of gas for combustible gas is parts per million, again, sort of like CO, or exactly like CO, or percent LEL or percent UEL. So as it goes through different phases, the ppm measurement is a lot lower concentration. The percent LEL gets to be higher concentration, and we'll show you how that kind of scale works. And again, this just goes back to basic, actually it's math. 10,000 ppm equals 1% by volume. That's another way of measuring just what is the concentration, what's the mixture, how much sugar is in the iced tea. That's what ppm tells you, that's what percent by volume tells you. But the fact with the upper and lower explosive limit, that is more about the type of gas that you actually have. So parts per million is just purely concentration. It's just a ratio of what gas you have to the gas that to the rest of the available air. Whereas the percent LEL or percent UEL relates to the type of gas. It's the characteristic of the gas. And we'll be talking about two main gases here, methane and also propane. So again, you probably know this from your BPI training. Combustion analysis, 1 part per million is 1 in 1 million parts. And just to give you an idea of the scope of it, it's like a dropper of oil in a 5,000 gallon pool. That's 1 part per million. That's not very much at all, but these analyzers, the detectors, the sensors are able to detect the concentrations that low. So when you get down to 1 ppm, it's 1/10,000th of a percent. And then 10,000 ppm is 1%. You can see the scale on the left as things progress, just to give you an idea. So again, we were talking about the technology here. Inside the sensor is actually a solid state material that's treated to respond to combustible gases. And it's actually heated to a high temperature. Now, the design is made to be intrinsically safe, which is a important characteristic for the BPI 1200, such that that heat cannot actually cause a source of ignition for the product. So this is a very cleverly designed piece of equipment. So the gas burns on the sensor, and the sensor also has probes or wires connected to it to sense its resistance. As the concentration of gas burns on the sensor, it changes the resistance, and then a microprocessor translates this resistance change to the digital display of the values of concentration. So that's what's actually being calibrated here, is how much does the resistance in the sensor change compared to the gas concentration. And these values become meaningful. It's not just a shot in the dark here, but there's very scrupulous design. There's calibration that's required to get the digital number out. What you're looking at here is the sensor. This is actually a screenshot from a sensor specification. It's actually a logarithmic response. So it has to interpret that logarithmic response in order to give you the concentration. So we'll go over again, two different gases, mainly two different combustible gases that you're going to encounter in residential situations are propane, which conforms with the National Fire Protection Association 58, the LP gas code. The lower explosive limit for propane is 2.15% gas. And that's probably the main one you have to remember, or at least be aware of. When you get to the upper explosive, we really don't want you folks working in anywhere above the lower explosive. In fact, you're going to find out that BPI says it's only 10% of the lower explosive limit, and that's basically a no-go situation from there. They want you out. So it's a very safe illustration or use of this product, is that you'll be only 10% of the LEL. But for information, the upper explosive limit is 9.6% gas. For natural gas, and methane is usually between 92 and 98% of natural gas. So we just generally kind of lump it in together and say natural gas is, in quotes, methane, mainly methane. 5% gas is the lower explosive limit for natural gas or for methane, and 15% is the upper explosive. So here's where the LEL is a factor of the gas. This is what I'm trying to illustrate here. You can use a Sensit HXG-2D or any similar product calibrated on methane for use with propane, but you got to know it's going to respond differently. So we're going to be talking about the, if it's calibrated for one, you can still use it for the other, but you have to be aware of the change in scale between the two. And then these concentrations are for normal atmospheres, basically where there's just 100, excuse me, not 100%, but 20.9% oxygen present. If you're in a situation where, for whatever reason, maybe an industrial situation where there's more oxygen, then everything changes here. All the ratios change. So here's an illustration of going through the response of the product between 10 and over 50,000 ppm. ppm and percent gas are really the same thing we talked about. It's just a concentration factor. So you'll see here, we're just sort of sliding the decimal point around, okay? It's being slid around several places, 10,000, a factor of 10,000, in fact, because that's the difference between a percent and a ppm. So that's really what we're trying to show here. The box here shows the unit can be set to display in parts per million up to a certain point, and then it will switch over to displaying in percent LEL. And if it's calibrated for methane, here's where things switch over. So it can switch over here at 2% LEL, which again, the BPI action level for the work you'll be doing is 10%. So you're well within the range here as you move up. But if the meter's ever set differently, this is to give you an idea of the difference here. And I can actually, excuse me, send you this chart. I'll make a note here. I do have a screenshot of this chart that I can send to you if you're interested. I'll send it to Sean and Kyle, and they can distribute it as need be. So when you get into the range here above 10%, this is the factory setting for the alarm, which is exactly where BPI specifies in the BPI 1200 standard that it should go off. So the display will go from parts per million. That means you have a small concentration. And then it will shift over to LEL. When LEL becomes important, when you're getting that 2% range, then it starts to become important to look at LEL. And then your alarm level is 10% here. So this is what you're going to see is this, the yellow band, the box here. It's going to transition from ppm. Then it will cut over to display LEL when it's important to know that value. And one other thing, 100% LEL is 5% gas or 50,000 ppm. You never want to be there, but you can be in that, you know, that's mathematics here is what's happening. So for propane, for propane, it's 2.15% LEL. Propane has basically, it's C3H8. It's got more carbon in it. It's got more energy trapped in it versus methane, which is CH4. It's really the carbon combining with oxygen that gives you sort of the energy that you release in the fuel. So because propane has more carbon, it actually is a more powerful, more energy dense fuel, which means it has an ability to release more energy at lower levels. So basically, if you're using if your unit's calibrated to propane, you would be switching over at about 1,000 parts per million, switching over to around 4.6% propane. Now you can see here that the action level for propane at 10% LEL, which again would be the BPI action level, is now 4.3% methane. Okay, so this means if you're using a methane unit, methane calibrated HXG-2D on a propane system or propane gas, and you know propane's present, you're going to have an action level which is sooner than you would if you were measuring methane. So 4.3%, that's something to keep in mind. This is the actual mathematical conversion of where a methane unit is actually reading propane. It's this ratio here. It's about 2.5 or so. I'll let you linger on that for a second. That's important to know if you're measuring propane, that you're not looking for 10% LEL, you're looking for 4.3%, and you won't get alarm till you get 10 if it's a methane calibrated unit. Some other properties you need to be aware of between these two different gases. Propane is a heavier gas. It's got more carbon in it. It blankets or it drops. It's about 1.5 times heavier than air at 60 degrees Fahrenheit. Propane is actually odorless and colorless, but for commercial purposes, mercaptans or sulfides are added to detect it by smell. And again, that LEL is 2.15% gas. Methane, on the other hand, is lighter than air, only about half as dense as air. So it will move towards the top of a confined space, even a room or a basement or anything like that. Methane is colorless, odorless also, and it has treatments added to make it detectable by smell. So this would be a little hack or something you should know. If you're measuring propane, a propane leak in a propane system, and you're in the ppm level, you should have the probe below for propane, below where the source of leak may be, and for methane above. So if it's a pipe, measuring above the pipe, because methane is going to have a tendency to leak out and then to rise in the atmosphere. Well, propane will actually do the opposite, which will leak out and drop in the atmosphere. So we'll talk about intrinsic safety now. So this is, again, developed for utilities and fire departments, but it's a great tool. It's for what it does for the building performance industry. So intrinsic safety means the equipment itself doesn't have enough energy in it under normal or abnormal conditions to spark ignition in a hazardous atmosphere. Okay, so that's what you're measuring is basically you're measuring sort of pre-event hazardous atmospheres by having a measurement of the concentration of gas. So this is achieved by limiting the power. This is by design, the power that's available inside the equipment, inside the unit in your hand, which will ignite the gas. So intrinsic means by design, but you, the user involved in this process, you must use it as it's designed. That's why we're going through this course today, so you understand how to use it. So to get a fire or explosion, this then goes back to your kind of combustion safety training. Fuel, oxygen, and a source of ignition are required in order to get combustion. You need to have all three things present in the right ratios, the right balance. So think about, we just talked about the explosive limits are a ratio between the amount of fuel, the gaseous fuel, and the oxygen that has to be present in the right concentration or range of concentrations, that red band in the little illustration we had earlier, and then the source of ignition, which would cause combustion to start taking place. So they got to be the same place, the same time, the right amounts. An intrinsically safe product, it assumes, basically says, bottom line, everything's going to be dangerous. Where I'm using this product, it will be dangerous. So if it assumes that it's in dangerous concentrations, the unit itself has to limit its own energy so it can never be the source of ignition. So it's an intrinsically safe tool to use in situations where there's combustible levels, concentrations of fuel and air present. Okay, now we'll jump to the BPI 1200 standard. And this is actually available, downloadable online. It was originally released in its first iteration in 2015, and then it was updated in 2017. I was actually on the committee and was a resource to them at different points. It does take a long time to issue standards, so I was back and forth on and off the committee, but I'm still in touch with them and giving them feedback from the field, from our perspectives at TruTech, to make sure it's a workable standard, works with the equipment that's on the market, and it works well and people are trained well to use it. If you want to download it, you can go to this link. You have to copy the link exactly as it is. That means uppercase BPI. So it's bit.ly, bit.ly /uppercase BPI -1200. And you'll also get a set of the slides if you haven't received them already. So this is already in there. The combustible gas detectors are in section 7.1. We're going to actually go in right now and examine 7.1 now that we gave you an illustration of how the product works, what's it's made of, why it was designed. We're going to talk about its application or use. So I call this test instrument survivor. This is to show you how we ended up, BPI ended up sort of specifying pretty much exclusively the Sensit HXG-2D. It wasn't that they picked a manufacturer, it was the specifications led you there. So I'm going to go through the 3 or 4 essential elements of the standard, which ended up making the Sensit HXG-2D sort of the winner here, the survivor. So this section, 7.1.1.1, gotta love standards language. A combustible gas detector shall be intrinsically safe. So that means all these sort of maybe a new brand to you, Sensit, because they've been in the industry for utilities and fire departments. Of course, they're all intrinsically safe. The Bacharach Leakator 10, the Leakator Junior are intrinsically safe. The TIF instruments are intrinsically safe. However, the Testo 316.1 is not intrinsically safe. So that means Testo gets booted from the island at step 1 at 7.1.1.1. Okay, let's see what the next standard specification brings. A variable tick rate. All the products we just mentioned before, the survivors are still there. They all have a variable tick rate. That was an important part of the standard VPI developed with cross the industry representation of the committee. Products with an LEL alarm or display, these 3 were the only ones out of the remaining ones that came up with that had an LEL alarm or display. So the Sensit TKX, the Bacharach does not have an LEL display. The TIFs do not have LEL alarms or displays. If they had either one of those, they'd probably still be in the running and still be on the island. And then calibrating and zeroing, the final choice is the last step in the standard. Some of those other products have this ability, but they don't have the other requirements that led to this point. So out of this full list of products, many of them are more advanced products for the utility and the fire department industry, but the basic one, the Sensit HXG-2D, that just does pretty much dedicated purpose combustible gas measurement leak detection, that was the winner, the survivor. So what does it actually do? What's actually happening with the product? It tells you if you have gases in an area. And so that's for investigation purposes, to know if there's anything present in the area, any combustible gases present in the area. It also alarms if the concentration approaches or is explosive, and that's for warning or evacuation. So you can see the upper screen display, it's got 130 ppm gas. We talked about how it switches over between reading ppm up to 990, and then when you get higher concentrations, it'll move to percent gas. So this is percent gas, 11.5% gas, which is well above for methane, the 5% level, and well above for propane, the 2.15% level. And you can see, maybe you can see, but the alarm will be going off and you'd hear an audible alarm. So it's for investigation and safety purposes, evacuation. So it's a tool you can use to do your work, to find the fuel leaks, which are important about energy efficiency in the building, just, not wasting resources. And then also if that fuel happens to leak and get into a concentration where it becomes dangerous. So if you haven't already, maybe I can move through this kind of quickly, but there's a torque screw. That's why they give you the torque screwdriver with the unit. It comes with it. Remove the screw, depress the retaining tab, which is sort of the latch for it. And you can use a coin. If you use like the tip of a flat blade screwdriver, you end up usually gouging that. So it's best really to use a coin to unlatch it and then slide the sleeve down. And just make sure you observe the battery polarity. It actually is molded in the side of the case if you hadn't noticed it here, but it shows you how the battery should stack up, the 3C cells with the minus to the left and the plus to the right. It's sort of subtle there, but it is there if you ever get mistaken about which way the batteries get connected. So of course, to power it on, you hit the power button. We talked about these buttons having multiple purposes on them. You need to press and hold to get it to power on. And then once the unit powers up, you hear power up, you can release the button. You want to allow the unit to completely warm up in an uncontaminated environment in order to kind of get its baseline. This is sort of like calibrating your carbon monoxide meter before you do a test. And in this case, it automatically moves through and decides when it's done. So it can be anywhere from 40 to 180 seconds. I think generally it's dependent upon the temperature of the unit. And we do recommend that you place the unit, you keep it warm and keep it inside, just like any good product that you have. To power it off, again, you go towards that power button, press and hold to 5 seconds. They really want to make sure you meant to turn it off. So you have to push and hold it down and then release it once you hear the unit power off. The unit does not auto power off. It's in that kind of regime of safety products where you don't want it to stop working for you, because you can actually leave it on if you're doing work. If there's any chance you think the concentration of combustible gases might change, I mean, you're just talking about batteries, leave the unit on. It's going to scream when it goes above 10% LEL. The LEDs on it, the one on the left, of course, indicates the instrument's ready for use after it goes through the power up mode. It also indicates charging if you have one that allows rechargeable batteries. There is a different model, HXG-2D, which does allow rechargeable batteries. When the battery icon is illuminated and the LED is flashing, that means you're moving towards running out of battery power. It gives you an early warning of about 15 minutes that you'll need to replace the battery, so you aren't left hanging without the ability perhaps to at least complete your task or at least move to a safe area. And the red LED on the right indicates the preset alarm points have been exceeded. And we talked about the preset alarm. For the methane calibrated one is 10% LEL, which exactly conforms to the BPI standard for methane. So to start up, this is just going to walk through what's happening on the display. Maybe this is good for some kind of future trivia question. I don't know, but we'll just walk through it all. You want to do this in fresh air. All the segments will come on the display. The backlight will go on and off. Again, it's checking itself out. It'll display S, which is Sensit. 2D is the model number on the screen. The software version, because it is running software inside it. It'll display CH4, which is an abbreviation, chemical abbreviation for methane, or PRO, to indicate that it's calibrated primarily to propane gas. So that's where you can tell, because there's really actually no outside marking on the unit, that it would just be in the display when you power it up. It'll also display if it's at 50% or 10%, indicating the LEL calibration point, and the ones you'll have will be at 10%. And then also indicating display whether it's resolving ppm, percent LEL, or both. Then next will be the alarm set point. And then the alarm will actually sound itself to make sure it's working, and the red LED will flash, and you'll hear 3 beeps to let you know that the alarm is in effect working as it goes through its startup cycle. They'll continue to flash all these segments until the warm-up's final and attained, and that's usually no more than 5 minutes. And if you are zeroing it, it'll come up with 0, indicating fresh air zeroing. And then the full working display is shown up on at the end of the sequence. So it's actually a pretty smart meter. It's doing a lot of stuff behind the scenes, that it's actually going through all these steps. That's what's happening when you hear it making all these noises when you start it up. It's actually doing a lot of stuff to make sure it's functioning properly and taking care of you. If you ever see fail displayed on the screen, make sure take the instrument to clean air, push and hold the 0 button until auto 0 is displayed, and then let it go through the zeroing process. If that doesn't clear the fail word on the display, that could indicate an instrument or more likely a sensor problem. And again, these are $45 sensors. So, but it is important to know, these sensors also have no shelf life. So if you want to be proactive and get some sensors in advance to have them on hand, they're just small little things, but they're very important. It's crucial to the operation of the product. To do ambient air testing, and this would be sort of your investigation standpoint, you would power up the product, as we talked about. And so you power up before you enter the area to be tested, and you observe the display. Of course, it'll have the audible on it, but you just want to see what's happening with the concentration as I move into this area. So levels indicated in parts per million are smaller amounts of leakage, okay? So make sure when you take a good hard look at the screen, is it reading ppm or LEL? ppm means it's tiny amounts. LEL means it's much larger amounts. You want to be cautious as you move through the area, and also be cautious about reading the display. So if you approach the 10% LEL level, you want to make sure that you're ready to get out, because you're really in an area where sorry, you're not qualified to work unless you also are a volunteer firefighter. Um, these are areas which can become dangerous very quickly. If you smell gas, you can test by using the tick rate, so the increasing tick rate. So if your environment you're well below the lower explosive limit, you haven't even switched over on the screen, and you want to locate the source of the odor, so you're locating a fuel leak, press the tick button, which has the B on it. Just tap the tick button and you'll start hearing the tick rate. The instrument, as you move closer to the combustible source and the concentration increases, the tick rate will increase as it goes along. And then if you find yourself that the tick rate is hit, is just like kind of going crazy, that means you've kind of saturated at that point. You hit the button again to reset it to a different threshold to get a new starting point to start hearing the tick rate again and continue to move and can finish your investigation. So this is the equivalent of your Leakator 10, where you adjust the thumb wheel to get it to slow down again. But this is done because it's digital. You don't do it by pressing a button. I believe there's 3 levels of tick rate change. So you can go from most sensitive to less sensitive to least sensitive. And that, by sensitive, it means able to distinguish concentrations by tick rate. If you just want to stop the tick rate, just hit the A button, tap the A button. It says mute on it. It will quiet the tick rate. So when using this product, again, the users involved. It was designed a certain way, but there's a person using it. So you got to know how to scan in order to get an effective use of the product by the way it was designed. The sensor does need a little bit of time to react. They're not instantaneous. It's not sensing light or anything like that. The gas actually has to make its way to the sensor, and it has to burn and change the concentration on the sensor and then be reacted to on the display. So moving it too quickly can result in missing things. So you want to move the probe head at about 1 inch per second. So count to 10 as you move about a foot. Everyone I think can visualize a foot. I mean, heck, look down at your own foot. That's a foot or so. And count to 10 as you move about a foot. That gives there sufficient time for it to react. If you hear the tick rate go up, or you see the display concentration go up, that means you're moving towards higher concentration. If it goes down, that means you're likely moving away from it. And also keep in mind that propane drops in blankets and methane rises. So be looking on the right side of the piping or valves or fittings or whatever as you move around to do your leak detection examination. So you can also use pipe dope I'll make a comment about pipe dope and leak detection fluids. Sometimes vapors, if it's a newly installed system, vapors from the pipe dope that's used to seal the pipe as it's brought together, gas piping, or even some leak detection fluids, have some volatiles in them, which can be sensed by the sensor in the product, by the HXG-2D, to make it seem like it's actually sensing gas. So you can use the tick button to reset the tick level to a new or higher level so that you can kind of get away from those background levels of concentrations. Or use it prior to using leak detection fluid. And that's in fact what a lot of people do is they'll get it a real close general vicinity with the leak detector. And if it isn't obvious, then hit it with some leak detection fluid, which we also sell at TruTech, but you can get it pretty much anywhere, to then see the bubbles and know that at that point you're leaking from the pipe, you're leaking fuel from the pipe. So we talked about volatile chemicals. Other volatile chemicals have combustible gases in them. They can be cross-sensitive for the product. So things like paints, propellants, oils, chemical cleaners, paint thinners, gasoline, kerosene, they can all cause the product to react. If that's the case, you should know it because you're around those products, and they may be giving you a false signal. So again, this is operator awareness where you use the products. Here's a cross-sensitivity chart that I've mentioned, this cross-sensitivity training here, that I mentioned a little while ago. And this just gives you an idea of the compounds, gases or vapors. And there's some refrigerants down here. But for the Sensit HXG-2D and all these products here, they basically use the same sensor. Here's for people who understand chemistry, what the formulas are for these products. This is the point at which the HXG-2D will detect it. This is the 100% LEL level of this gas. You can see methane's 5, propane, they rounded up from 2.15 to 2.2. And then at 10% LEL, this is actually the reading you would see on the screen. So you would, at 10% LEL, you would see about a 6 on your HXG-2D for propane. So just, again, this is awareness that if you're measuring propane, you're going to have in mind a lower number than 10% for your time when you're at the 10% LEL level. So the product itself, just to kind of cursorily go over the product specifications, does have a broad operating temperature. It was designed to be used in the field. The battery life, it's heavy because it's got 3C batteries, but it's meant to be used continuously, kind of to, again, for the first responders and utility workers to take your worry out of running out of battery too early. It is designed to meet European and US standards for intrinsic safety. And we'll dig into what these factors for the US standard mean right here. So class 1 for an intrinsically safe product, you can use it where you know flammable gases may be present in sufficient quantities. Division 1s, this means that flammable gases are likely to be there. And then group C here means atmospheres containing ethyl vapors, and group D containing all sort of the typical combustibles and solvents that you might encounter. So this really gets into a lot of detail, the way these products are designed. There's actually a whole nother standard like the BPI 1200 standard, but much more intense behind this for the development of this product. And the temperature class at which it can be operated up to the gas temperatures. That's the T3. So this is made in Valparaiso, Indiana, by a company that started as a family-owned company about 40 years ago called Sensit Technologies. So service and maintenance, you want to store it in a warm area, make sure you take it in overnight, kind of like your combustion analyzer. Wrap the gooseneck around, it keeps it from getting damaged and just kind of flopping around in your tool bag or tool case. Put it in a counterclockwise circle, loop it around behind and clip it in front. You want to make sure it's maintained by factory authorized technicians with approved parts, which TruTech does have replacement parts, and we do factory calibrations for it. And anytime you have an overload reading or you've exposed it to silicons or waxes, you want to check the calibration. That means like if a floor has just been buffed, something like that, these compounds can actually coat the surface of the sensor and not allow it to react with the combustible gases. So that gets into a sort of a dangerous situation. And a simple response test is taken on lead cigarette lighter and just flick it, not the flames, but just the gas only. This is not calibration, but this is a response test, sometimes in the industry called a bump test. You're just bumping it, you're nudging it, sort of like that person sitting next to you right now who's falling asleep. You bump them just to see if they're awake and alive. So you can change the sensor filter or change the sensor itself. You remove the sensor cap by pressing the retaining tab, which is located on the side of the sensor, inside this cap area of the sensor, and pull it up and away. There's a filter, a disc filter, which will be loose inside. That's the filter inside. It's a little pre-cut material. So you want to clean that area. If it looks contaminated or dirty, clean the filter and the cap with a mild soap and water, and you want to make sure it's thoroughly dry before you reinstall it. And then put the cap on inside the base, and then you slip it over the top of the base until the tab clicks back in place. And the sensor is about $46, and it's also inside there. It's keyed. It has, I believe, 4 little legs on it. It has a tab which keys it. You just got to make sure you put it in the correct orientation, because those are actually leads and they mean something to the unit to be installed correctly. So the field calibration kits are pretty simple. It's calibration gas, kind of looks like a can of propane, but it's actually calibration gas to a specific level, a regulator to flow the gas, a cap to put over the sensor, and then a fitting to attach it to the tank. And there's actually a calibration video. Again, you get a copy of these slides if you want to go look at that. And just to review, not to train you in calibration here, but just say it's you enter into a specific mode in the meter that's indicated in the instruction manual. You flow the gas from the calibration tank, wait for a response, and either the unit auto cals or it comes back bad. So there's a lot of automation built into it. They made it really pretty simple to calibrate it. Okay, we've now arrived at the knowledge retention quiz. I'm going to step through it, and hopefully you have a copy of the quiz in front of you, and we'll just, I'll leave the screen up for about, I'm not sure, about 5 minutes or so per page, 4 to 5 minutes, and just give you a chance to take a look at it. And if anybody in the other end wants to type me a message to change the mode at which I go through this, please do so. Okay, so just ponder over this first question. Maybe if you have something to write on. The Sensit HXG-2D is designed to detect and measure propane, natural gas, and also CO. Is that true or false? So if you can note all the conditions where the danger of explosion or flammability is not usually present. Where is it not usually present? Think back to that chart that was shown within the first few slides there. What is the LEL or the LFL, because it's the same thing, for methane? Is it 5% gas, 50 ppm gas, 100% gas, or 2 ppm gas? What are all the things necessary for a fire or explosion? In question 2, excuse me, 2 answers, and question 4, more than 1. So far, all the other questions just have a single answer. So note all the things necessary for fire or explosion. We talked about a certain geometric shape. It might give you an idea of how many there are. Is it normal for this HXG-2D to activate an alarm sound in an LED upon power up, or is that indicating an abnormal condition? True or false? Is it normal? The HXG-2D can be reset to a new tick rate starting point by pressing which of the following buttons, and the labels are actually given there. The B button, which says tick or cal, the A button, which says power or mute, C button, which says light or zero, or do you do that by removing the batteries and restarting the product? Tick rate, starting point, reset. What is a ppm? 4 different choices there. What's a good scanning rate to test an area for gas leakage? 1 inch per second, 1 mile per hour, as fast as possible? Or should you just remove the batteries and restart and go at whatever rate you wish? What should you do if the tick rate gets too fast to pinpoint a leak? Just shut off the meter, move the probe faster, reset the tick rate where you're standing, or remove the batteries and restart the product. When you go to auto zero, the HXG-2D, it's important to hold the instrument inverted or upside down, to twist the probe counterclockwise to make sure the instrument's in clean air, or keep the backlight shut off. Which of these factors is important when you auto zero? I don't have any music. It's probably copyrighted. Okay, I think we'll go ahead and review the answers here. Just see how you did. So it is not designed to measure CO. We stressed that at the beginning. So that's false. When the whole statement's made there, it's false that it also measures CO. The area where the danger is not present is above the UEL, because that's when it's too fuel rich, or below the LFL, the lower flammability limit, because that's not enough fuel for the amount of oxygen present. The LEL for methane is 5% gas. And then the things that are necessary for a fire or explosion are oxygen, the combustion triangle, oxygen, source of ignition, and a fuel. And then yes, the HXG-2D does go through an activation sequence where things are going to go off on you. So it's true, you're going to hear some normal startup sequences, which will indicate the alarm, but only briefly. And then you reset the new tick rate. The big clue here is the tick cal button is what you use to reset the tick rate. So it's pressing the B button, which says tick or cal on it. That gets you a new threshold on your gas detection, your inspection mode. ppm is a part per million. I'm sure everybody probably got that one. Then a good scanning rate is about 1 inch per second. Give the meter a chance to react. And if it starts to tick too fast when you're trying to pinpoint a leak, reset the tick rate to where you are, and then auto zero to make sure the instrument's in clean air. I'm thinking about something here. I think there were actually 11 questions that I sent you. And I apologize that the slides didn't align with the quiz. So maybe that was a free one or whatever. So that's really it. We did that in about an hour. We do have some resources on our, the Sensit website has a manual quick start guide and a brochure. Of course, the product's available on the TruTech website. There's also a quick start video, which is at this link here, this bit.ly link here, which is a Sensit product, but it tells you how to go through the process of pretty much doing what we did here in this training, but it's a good reminder.